Sir, now you please start.
Okay.
Sorry
So
to all the
today,
participants. Now you please join
today's,
early.
today's class, I'll start one of the very important, data structure of Python. That is the tuple. Yesterday, we have finished the list data structure, but there is some difference, between list and tuple. And a tuple is similar to the list in many ways. Like list, tuples contain the collection of items of different data types. That is already mentioned. A tuple is a collection which is ordered and unchangeable. This is very important. If you give the tuple in your Python code, you can never change. But if you give your data in the list form, you can change it. So that is the difference between list and tuple. The type items of the tuple, same as list, are separated with a comma, but enclosed in the parameter that is the first bracket. So if I use the third bracket, that means list. If I use the first bracket, that means tuple. That's why a tuple is the read-only data structure. As we cannot modify the size and value of the items of it. Suppose a tuple containing, say, length of tuple is say 9 elements. So what is the length? Size is the 9, and some 9 values are given. We can never change the size, also the value. But in case of list, we can change the size as well as the values. And tuple items are indexed same as the list. First item has the index 0, second item has the index 1. Similarly, the negative index is possible. So definitely, for example, if I give the tuple -1, it indicates the last element. If we give the tuple -2, that is the second last from the n, and so on. So how can I create tuple? Suppose I want to create a tuple, so name is the Pyrhon, Pyrhon. So this is my tuple T1 because I have given the first bracket. And this is, we can print the type 1. So what is the type of T1? If I give the print command, so definitely the output, what is the type of T1? Similarly, creating a tuple with a single element, say Python.
Sir,
Hello?
I'm देखती sir.
Hello? So if I write this code, so we get, first of all, the Python type is the class string, and this is the class tuple, class tuple. So there are only two Python code. One is the print type, where the comma is not given. Here the comma is given. So when I have given the comma, then the class is tuple. And when the comma is not given, then it is treated as a string. So this is very, very important when you solve any statistical problem, okay, an optimization problem, or better to say machine learning problem. So this is, say, display the tuple unique index. Suppose we have written t equal to 1, 2, 3. So print t1, suppose. Then tuple input, enter the values elements, and enter the values elements, and print t2, count 0. For I in t2, suppose if I give this this, what is the count plus 1? So display the tuple elements using index. That is a very interesting. So when I have given the tuple units, say 1, 2, 3, 4, then the tuple elements are, I have put, enter the elements, say 9, 3, 9, 8, 7, 6, 5, 4. I have given the tuple elements 9, 8, 7, 6, 5, 4. Then, since it's a tuple, then how we can print T2? We'll give the inverted comma separated by a comma, 9, 8, 7, 6, 5, 4. That means it creates a tuple. And what is the first index? That is the 0 index is 9, first element. 1 is 8. 1 is 8. 2 is 7, and so on. And because we have given for I in T2, and we are using count plus 1. So that means first we get the first index, then second index, and third index. I am telling you, this command is not useful for our which we are doing in the social science research. Mainly, I am showing the application of this. So these are the tuple functions, already same as the list command. We can use the length command, minimization command, max command, count, index, sorted, like list. So similarly, there are so many problems of tuple. So I'm going the next part, which is very, very important. That is the dictionary part. I'm telling you, this we use when I go for the statistical programming. Okay. So what is Python dictionary? That is, Python dictionary is used to store the data. Just to remember this part, this is very important, key value pair format. So dictionary containing this pair format like key value. So there are two terms, one is the key and one is value. So you have to know what is the meaning of key. What is the meaning of key? And you have to know what is the meaning of value. So just to think here, the keys must be a single element. Values can be any type. That means such be the values may be the list, values may be the tuple, values may be the integer, etc. And it is also the mutable data structure. So that means the dictionary is defined into element, keys, and values. So again, repeat, this is very, very important. So I will show you so many things using this dictionary command, that how you create the data using dictionary in Python. Okay. So what is dictionary is, again repeat, used to store the data in a key value pair format. So what is key? Keys must be a single element, and values can be any type, such as list, tuple, integer, etc. And when you write any dictionary in Python, so then we apply the symbol, that is the curly brackets, second bracket, and each key is separated from its value by the colon. So this is the syntax of to write how we write the dictionary. Again, repeat. In dictionary, we have to know what is the key, what is the value, and key must be a single element, and it is written enclosed with the curly brackets. That means second brackets, and each key is separated from its value by the colon. Say I am giving simple example. Then name. I want to create one dictionary. That is, the name is the Omid and age is the 25. So we can say here name is a key, and what is the value of the name? Omid. Age is the key. What is the value of the age? Is 25. And just to think, we have written this thing in a second bracket. That is the curly brackets. And separated, key and value is separated by colon. Okay. This is very, very important. It's separated from it by the colon. And this is, so I'm telling you, say write a program to create a dictionary. This is very important. So I want to create an empty dictionary where there is no item. No item. So this is the empty dictionary, only two curly brackets. So print empty dictionary, print dictionary. So what we will get? We get this, only this second bracket. Because print empty dictionary, what is this? This is only second bracket. Because we are, how many printing command we have given? 2. So first print command we have given this, the empty dictionary. Second print command is given the only second. Create a dictionary with the dictionary method. Suppose I want to create a dictionary, say my key is 1 separated by colon and the value is Java. and then comma, another part, 2 is key value is Python, 3 is key value is C++, and print dictionary, same thing. If we go put this is a second command will be coming. In this way, we can create this type of dictionary. So I'm not going in detail for this. I am going to the main application for Python, because that means we understand when you go for programming in Python, so then what things we need. We need the concept of already discussed the variable type. We need to discuss the your for loop statement, that is the decision making statement, and then we need the data structure, list, tuple, and dictionary mainly. And after this, which is the most important part, now I'll start, that is the function part. So today, I'll start from function. I'll discuss function, what is meaning of the module, and what is the meaning of library and packages. That is my the today's class. And to the concept, give the concept of function, module, list, and we need this all concept, list, tuple, and dictionary. Okay. So initially, I would like to give one snapshot, why we need this concept. This is a snapshot. So today, actually, my discussion is functions, modules, and packages and libraries. So this is a snapshot I'll give. Then I will explain detailing. I'll explain detailing about the function, detailing about the modules, detailing about the packages, and detailing about the libraries. So then, what is basically function? A function is actually we studied function from 9-10 class. So maximum function. That's why not to give the mathematical definition of function. But in case of computer programming language, any language like C, C++, and in total Python, basically machine learning, deep learning based on this function. Okay. And function is the basis. So what is function? The function is the block of reusable code that performs a specific task. That means we can use the so many same type of code number of times. So it is a block of reusable code that performs a specific task. So we can write our own function. Also, we can write our built-in function. So functions are divided into two parts. One is the inbuilt function, and that is the user-defined functions. We can build our functions. So like what is the built-in function? The print, length, already it is built in Python. Okay. So this is the snapshot of function. Then after, when you go for when you understand function, then you can create different modules of Python. Now modules is a single .py file. Module is a single .py file. When I start our computer, so we can create a Word file, Excel file. So simple, that is basically a single file. And after creating so many files, so we put them in directory. That part I'm coming. So a module is a single .py file that contains a Python code, and that code may be functions, and that code may be the classes because it is object oriented, or the variables, and which can be reused on other Python script using import. This is the very, very important. That is, what is module? Module is a single .py file that contains the Python code, could be function. This Python code may be the functions, maybe the classes, or maybe the variables, which can be reused on other Python script using import. So in one word, we can say using so many functions on so many classes, so many variables, we can create a single module, that we can say. And that, for instance, there is a file named, say, as math_utils.py. Suppose this is my single file. And this single file containing some function, this is my defined function. That is, the function is the addition of two variables. And definitely when you give the function name, and there is some return statement. So what is the return? Because addition means a plus b. So we can use this file in another file like we can import, because this function written in this module. This function is written in, this is the math_utils module. So then since this function is written in math_utils, so we have to import this module. And that's why we are importing this math_util, where this function is written. And that's why if we print math_utils.add 23, so definitely we get the value 5. So that is the application of module. Already function is defined in the module. Okay. So I will show you so many applications in tomorrow class. So this is the concept of modules. I'll show you that how to write a module program in Python. So then this is a very, very important part, packages. So already I told you that module is a single file. And naturally, we can say in our computer, there is called the folder, and folder containing so many, files. And that folder, we can say, we can create some directory. So a directory that contains multiple modules and has an, empty, there are so many file can be empty to mark as a package. So it is like a folder of related modules. What is the meaning of related module? Suppose I have some music modules. And for the music, there are so many types of music. Rabindra Sangeet is one module. Kishore Kumar is one module. Mannadi is one module. Say, Mukesh is one module. So using all types of folder, and that is basically a package. That is a package of music. Okay. So that is possibly with the also in a package, also sub package. So I'm giving a simple example of what is the package and what is the sub package. Okay. So suppose NumPy, which is very, very important packages in Python, that this is the, so many modules I have written. Init py, linear algebra, so many these things. And that means here NumPy is a package with a sub package like the code and linear algebra. So that means code is a sub package of NumPy and linear algebra is a sub package of the NumPy. That means what we understand. So when you import some package in Python, so that package containing so many sub packages. So that is the advantage of Python. If we import NumPy, so then so many work we can do under NumPy. And what is library? Finally, library. That is the collection of packages and modules designed to perform the specific task. So for example, NumPy and Pandas, these are very famous library in Python. And NumPy is basically used for the numerical computing. That part I will discuss separately. And it includes packages and modules, like already I told you, that is the NumPy is a library, but includes also some packages, also modules, like the NumPy.linear algebra. This is basically package, or you can say sub package, or NumPy.fft, etc. So that means if we arrange this, the visual representation of the hierarchy, which is very important, that library.numpy containing the package, the name is the NumPy.linear algebra. So that means this is linear algebra under the NumPy package. And under, what is the module? Because we know under linear algebra, there is the matrix. So module is the matrix. And under matrix, we know you are using the inverse. So that is basically a function. So that means we are from, what is the hierarchy? Function first, then module, then package, then library. That is the hierarchy presentation, visual representation of the hierarchy. And similarly, if we compute the module decomposition.py, obviously under some function is the eigenvalue. So a function eigenvalue that compares the package nillion algebra, and again this is the NumPy under package. So this is under library. So this is the hierarchy, visual representation of the hierarchy. So this is basically snapshot of this. Now, after giving the snapshot, after getting the snapshot, I'm going to the function in detail. Function in detail that is naturally there are so many things, but when you try to know this all concept, you have to know this for the function. What is the meaning of Python function? And what is the advantage of Python function? How we can create function, and how we call the function. And for function, there is some return statement and arguments in function. This is very, very important. Call by reference, types of arguments, scope of variables, and recursion. So these are the contents. Mainly, I'll go for only function. That is, the function is the block of organized, already I told, reusable code that is used to perform a single and related action. Already told. And already I told you there are two types of function. One is the user-defined function, and another built-in function. Built-in means already predefined. Okay. So what is the advantage of Python function? Now, using function, we can avoid the rewriting the same logic code again and again in a program. That is the advantage. We can call Python function multiple times in a program and anywhere in a program. That is very important. And we can track a large Python program easily when it is divided into multiple functions. And reusability is the main achievement of the Python function. So obviously, the Python calling is always overhead in a Python program. So these are basic advantage of Python function. So how we create the function? Suppose you want to create your, user-friendly function, not the built-in function. Built-in function means if we call the function, it will be coming. So definitely already it is built. Okay. So how we create the my user-defined function? That is there are some keyword, that is the def, define. So we have to write the defined function name, and within bracket these are called the parameters. And this is the parameters, basically these are called arguments. So I'm telling you, when you solve any graph, so in the graph, any graph, we have to say what is my x-axis, what is my y-axis, what is the name of the graph. So definitely there are some position to write this thing within the bracket, function bracket. So that is called the arguments. So definitely according to your work, according to your research, so definitely the arguments will change. Arguments will change. For some argument used in the graph, some argument used in the calculation of correlation, some argument calculation of the p-value, and so many things. Okay. So that's why we define the function name within bracket the parameter. Then we can write the function docstring, that is the document and string, function return expression. So this is very simple, the syntax, how we can write the function. So when the first statement of the function can be optional, the function block is started with the colon, everything is written here. So definitely I'm not reading it. I am trying to give the same simple example. Then you can understand what is the meaning of function. So this is my, user-defined functions. So I am defining a function, that is the defined function 1, that is we are no passing the parameters, and print my name is XYZ, I can say Gautam, and then function calling function 1. Suppose only 3 lines I have written. in the Ideal or Google Colab. So after writing, you need to know these are my input, and I know this is my output. What is my output? That is my name is XY. And then what is the meaning of it? So if this function one, if you use in the other places, then we get the same. That is the reusable thing. Okay. So, and for the using the return statement, I can use the function. I'm not going in detail. So now I'm going for the very, very important part, that is called the module, library and packages. So this is very important. I'll try my level best to show it, because to some extent it is complicated, because there are a lot of things. Just a minute, I'm telling you. Okay. Is it visible to all of you?
Yes, sir.
Okay. So now, I'll give you the concept of module. That is already I told you, that is the module based on function. So module is simply a file that contains a Python code. I'll take much more time for this, because I know the importance of module library and package in Python. Everywhere it is used. So module is simply a file that contains a Python code. It can define function, already I told you, classes and variables. And it can also include the runnable code. Modules allow you to organize your Python code into manageable and reusable pieces. That is, so many pieces of codes can be, in the module format. So already I told you that is the module is a single Python file, and with what is the extension? .py extension. So that can be imported into other Python programs or modules. Okay. So what is the example of module? Very interesting. Say, we have a file called math_operation.py. So this is my module. And we know under module, we have to write some function code. Under module. And this function, and for function, we need, there is some key value and also some function name, also some arguments. And we can say parameters. So we define def, the function name is add a comma b and return a plus b. Again, we write define subtract a comma b, return a minus b. So in this way, we can write division, multiplication, so many things. We can define the functions, okay? And we can import this module into another Python script. So what is that? That is the main.py. This is the documentation. So what is my module? Math_operation.py. This is my module name. And under module name is these are the different functions. One is the add function, one is the subtract function. I can use the multiple function, so many functions. So you can import this module into another Python script. And that is the main.py. Import. What is my module? Math_operation. I am importing this. And after importing, I want to print them under this module. What is the function add is coming? So I am written print. This is the module name, math_operations dot add, because that is the function. That is the function name, add 2,3, and definitely we get out. So this is the very interesting example of module, that how you can create a module using function. Now I'll go to the directly package.
Sir, one question, sir.
Yeah. Tell me.
Sir, actually, you have written import math operations, but you haven't given the extension .py. Is it not required?
No. This is already I have given when I
No,
create
you have
this math
written import
I'm
math
telling you,
operations.
math operation means already when it is created, it is actually it is created as a file. Then the extension is .py. But when I write in the Python code, then only I give the name of the file.
Okay, sir. Thank you.
So now I'm coming to the packages. Package. That is a package. I'm telling you, this is very, very important. That is the package is a collection of Python modules. Already I told you in my snapshot class, snapshot part. The package is a collection of Python modules, and it's a directory that contains a multiple modules. Already I told you music directory. Okay. Files, and it may also contain special files like int.py, indicate the directory of a Python package. So a package allows you, what is package? Allows you to structure the large code bases in a way that is easy to maintain and navigated by the grouping related modules together. So that means we can say package is so many collection of modules, Okay. That means if you can import the packages, so all modules will work. All modules will work one by one, the modules will start. Okay. So let's say we create a package called shape. Suppose, for example, that is a shapes, which has multiple modules. The shape is the directory structures. So these are called circle.py. Py is a module. Shape.square.py is a module. So there are so many modules. And this is the first line. That is underscore intit dot underscore dot py is a special file that marks the directory as a Python. Because we have to understand the directory. This is the Python package directory. So that means in that directory, that underscore init dot underscore dot py will be present. So that's why it is called a special file. Okay. So circle.py and square.py are the modules. So when I have dot circle.py, under this module, we can write so many functions. So we can find the area of the circle. We can find what is the perimeter of the circle. We can find what is the radius of the circle. So these are the functions we can define under circle.py. Similarly, under the square.py, so many things we can write. So these circle.py and circle.square.py are the modules that contain the logic for dealing with the different shapes. Now, example of circle.py. Already I told you circle.py is a module. And under this module, we have to write the function. Def area radius. Radius definitely return 3.14 into radius, that is the pi r square. So that means it is giving the area of the circle. We know this thing. So again, I am writing another module square.py. And under square.py, we are writing the functions. Define area, side, return side into side. We get the area of the square. Okay. So you can use the packages in a Python script like this. Say, very interesting. Because what is my package name? Package name is the shape. Package name is shape. And from this package, we can import the circle and square. We can import the modules. We are importing the modules from this shape package. So then we can use the print circle.area 5. We are getting by using pi r square. We are getting the area. We can use print square.area 4. We can get the. So just simply, we can use the packages in a Python script like this. We can import from, this is very, very important. So many times I will write from this, importing this. From SkyPad, I will write when I go for the statistical programming. From shape, import the circle, square, and this. So in a Python, a library, now I am coming the library. That is the last part. So what is the hierarchy? Function, module, package, and library. So in the Python, a library is a collection of pre-written code that provides the functionality for a specific task or a set of tasks. Library contains modules, functions, classes, objects that you can use to avoid reinventing the wheel. By using a library, you can easily access existing code to perform complex tasks without needing to write the underlying implementation. Yes, I'm coming to the point. So key points, these are very, very important key points about the Python library. That is, number one, a library is a set of functions, methods that allow you to perform common tasks such as reading files, working with data, performing mathematical operations, interacting with the web services, and more. So that is the pre-written code already given. Okay. And that's why, in the C language, it is called the inbuilt functions already made. Okay. Reusable. Libraries help you reuse the code efficiently, saving time and effort. That is the importance of library. And packages. In Python, a library can also consist of multiple modules or a package. That is the library. Multiple modules and packages, which are collection of Python files, that is the modules, and grouped together for a specific purpose. And then the external or built-in. There is a person, Python has both the standard libraries, which come, bundled with the Python, and third-party libraries, which you can install from external sources, like PyPy, the Python packages index. So these are there are some inbuilt standard library, and there are some third-party library that you can extract from the, if you install from the external sources. Okay. So these are the key points about the Python library. Now, why we use Python library? Because every time we need the library. Okay, and you will be really, I don't know whether I'm giving the correct, because this information I got from Google. So, one day I want to know how many library in Google, how many packages in Python, and this type of thing I have given in Google. So really I'm astonished. They are saying that now all time it is creating, and there are more than 1,30,000, 37,000 already packages, sub-packages, libraries are already made. Because there are so many applications we are doing in the using Python. Already yesterday I have shown the application of Python. So why use the Python library? The first of all, the efficiency. Libraries save you time by providing the pre-built solution to common problems. So if you apply the library, so definitely it will save the time. Reusability. Instead of writing your own functions for tasks like mathematical computation, file handling, or network request, you can simply import the relevant library. So that is the reusability. Community support. Library often come with the documentation, examples, and community support, making it easier to implement completely. So these are the why I use the Python library. So now I am coming, which is a very, very important for when I start my tomorrow's class. What are the types of library? In Python, libraries are categorized based on their functionality and the specific problems they help to solve. There are many types of library in Python, and they can be broadly classified into several categories. Python libraries are essential for various domains of development, including web development, data science, machine learning, automation, and more. And the types of library can be broadly classified into so many. I have written only something. There are some standard library. That is the built-in library provided with Python. Data science and machine learning, library for data analysis, manipulation, and modeling. Web development, some libraries are building with the web applications and APIs. The automation and scripting, libraries for automating tasks and scripting. Graphical user interface library, very important. the libraries for building graphical user interface, that part I will discuss in the last class. Game development, libraries for the creating games, networking, database libraries for SQL, SQL database, testing libraries for the unit testing, visualization, this part I will take, libraries for the data visualization, cryptography, and text processing. There are so many things. And there are just some of the most common categories. So Python rich ecosystem offers the thousands of libraries to typically, not why thousand, because under so many libraries, so many packages, so many sub packages. So to tackle virtually every problem. So for our requirements, we focus only on data science and machine learning library and visualization library. This is our requirement. Actually, we are doing my research, especially my research, only data science, machine learning, and visualization. So these two categories are essential for performing data analysis, building machine learning models, and data. These tools in these libraries will enable us to efficiency process analysis, analyze and present our data, which is the core of our task. I'm telling you. So mainly when you go for the basic statistical part on some numeric calculation, how to create some data frame, okay, how to modify the data frame, how to replace the data frame, and how to calculate the some summation, matrix multiplication, so many things. So mainly we apply this NumPy and Pandas library. Because why NumPy? Because this is the foundational library for the numerical computing. It provides, and within NumPy we can create so many lists. I'm telling you, because we can given some tuples. Similarly, in GitHub, we can create list also, tuple also, dictionary also, so many things we can create. But it provides support for multi-dimensional arrays. Only I'll tell you, because mainly what is the advantage? You can create maximum, the 2 dimension, one single dimension, 2 dimension. But using the NumPy, we can create the multi-dimensional arrays and variety of mathematical functions to perform operation on this arrays efficiently. So if we want to know what is the mathematical function, basically in case of Python, we can solve any kind of algebraic function, trigonometric function, inverse function, exponential function, logarithmic function. Also, some, any kind of complex function we can solve in the mathematical function. Not a hyperbolic function also you can solve to perform operation on this arrays efficiently. And another very, very famous library in Python that is called Pandas. And that is basically built for data manipulation. Suppose when you go for statistics, so we have to manipulate so many data. Okay, we have to analyze so many data. Okay, and naturally the data must be the big data, not the small data. So there and essentially, especially for structured data like tables, that means we can create a data frame. And it always easy handling of the missing data, data transformation, and filtering operation. So this is very, very important thing. That is a very nowadays it is very important issue how we can handle the missing data. Okay, and that's why in one software that is very important, SPSS, and in SPSS there is a module in the how to missing data analysis. So Python can handle easily the handling of the missing data. Okay. And this is one first package we'll apply library NumPy, Pandas, and then another mainly for our case we allow the scikit-learn. This is the popular library for machine learning. This scikit-learn is used for the machine learning that offers simple and efficient tools for data mining and data analysis. It includes an algorithm for classification, regression, clustering. Suppose you want to solve the clustering problem, obviously you import this library scikit-learn. Now, what is the meaning? This scikit-learn, under this scikit-learn library, there are so many packages. And under the packages, there are so many modules. And under these modules are so many functions already defined. So definitely already these are the inbuilt. So when you call this scikit-learn, So easily, just using the command, you get the results of the logistic regression and discriminant analysis. Okay. So, and then the TensorFlow and PyTorch. This is a very famous library. These are the powerful libraries for the deep learning. Those who are working in the deep learning, they have to use the TensorFlow and PyTorch. And the providing a comprehensive ecosystem to build, train, and deploy machine learning modules, particularly to test like the image recognition, natural language NLP, natural language processing, and neural net. So for doing this, these are very much in the now it is the AI age, and maximum computer science researcher, they are doing the research in the deep learning. And definitely when they are doing the research in Python and they are using this library TensorFlow and PyTorch. Okay. That means for their total deep learning modules, deep learning functions are already inbuilt in this library. Okay. And Keras, that is a very, very important library. That is the high-level neural networks API that runs on the top of TensorFlow, providing a simply an interface to build deep learning models. But I'm telling you, for our case, mainly for the social science research, we go for NumPy, Pandas, and Scikit. This is enough for us. Okay. And throughout the class, I will apply this is the NumPy, Pandas, and Scikit, and some library for the visualization purpose. So now what is NumPy? Now question is, you can tell me, sir, what is NumPy? The NumPy, that is basically it is called numerical Python, and it is an open source Python library that provides support for large multidimensional arrays and matrices. That is the NumPy, and allow with the collection of mathematical functions to operate on this array. That means there are so many mathematical functions, and if we want to operate, suppose I want to know, say, some sign of something. So if we don't import this library, this will not work. So if we want to do this work, suppose I input some data, say the value of x, and I want to this sign of x. This will not work until the NumPy library is not imported. Okay. So that is the application of the NumPy library. So it is widely used for numerical and scientific computing in Python and serves as the foundation for many other libraries such as SciPy and Pandas and Matplotlib and many. Okay. So that means when you try to create the SciPy, we need the help of NumPy. When you create this Pandas library, then we have to need the NumPy library because it is the numerical Python. And when we create the Matplotlib, basically used for the visualization purpose, we need this library. Because when you plot the graph, we need some numeric values along the x-axis and y-axis. So why is the NumPy important? Because NumPy, that is, first one is the efficiency. That is, NumPy provides the highly optimized performance for numerical operations, especially for the large data set. Its array objects are more efficient and faster than traditional Python list. I am telling you a very interesting example. Suppose I want to create a list with 1,000 data set. So we'll be mad after some time. So then if we create a list with 1,000 data sets, so I have to write 1,000 values. And when I run this list, so definitely it will be slow. Then what I'll do that because I have to efficient the memory. So we can, for the large, if we write this large data set, so obviously I need some library which will perform instead of some, this is the data structure. Maybe when we prepare the NumPy, we need this data structure. We need this variable type. Because when you prepare any library, you need the packages, you need the modules, you need the functions, everything. You need the tuple, you need the directory, everything you need. But why? And that's why it is efficiency. Because within NumPy, there are so many things. And faster than traditional Python list. What is the convenience? The NumPy allow for the vectorized operation. Vectorized operation means we can give some vector notation, which means that you can perform operation on entire arrays without using explicit loops, making code simpler and cleaner. So that part I will show you when I write the code. And interoperability, that is NumPy is compatible with other scientific libraries. This is very important. Other scientific libraries, that's why it is so strong. Other scientific libraries and integrates seamlessly with C, C++, and Fortran code. And you know the C, C++ is very, very, as well as the low level, middle level, and high level. So powerful. And initially, when you start the object-oriented, then definitely we have to know the C and C++. And Fortran is very important for formula translation. So making it easier to perform the high-level operations, while leveraging the low-level and high-performance code. And foundation for the other libraries. Already I told you that many scientific and data analysis libraries such as Pandas, Matplotlib, SciPy, and scikit-learn are built on the top of NumPy, making it indispensable for the data analysis and scientific community. So these are the main purpose why we use the NumPy library. And question is, in which position, but for which data we apply this NumPy, what to use NumPy. Now, NumPy is used in a variety of fields for the different purposes. One is the data analysis and manipulation. It is often used for handling large data set, already I told, performing statistical analysis, data cleaning, and manipulating data structures efficiently. So this is our objective. Definitely, I'll show you that how we can, using library, NumPy library, we can go for different statistical analysis, how we can clean the data, and how we can manipulate the data. And scientific computing, it is a core library for researchers and scientists performing the numerical simulations, solving the mathematical problems such as linear algebra, calculus, and performing the statistical operation. Now, this is NumPy also used for machine learning and deep learning. Because when we use the TensorFlow, for this TensorFlow, obviously we have to import NumPy first. Otherwise, the TensorFlow will not work. And for the PyTorch, we know these are used for the machine learning and deep learning. So the basis for their operation, it is used to handle large data set, manipulate different features, and implement machine learning models. So signal processing, we also need NumPy. And this is very interesting that for the financial modeling is used to handle financial data, performs time series analysis, and run the Monte Carlo simulation. So it satisfied a large domain for using the NumPy. Okay. So now I'm giving a simple example. How we create the NumPy library. So creating NumPy arrays. When you create the NumPy arrays, so this is the advantage when you apply the Google Colab. So no need to install this NumPy in the Google Colab. And when you write only import NumPy, automatically it is imported, no install. Okay, so that is import NumPy. This is the name of the library. And when you use the NumPy, what is the advantage? You name the short name for this library, that is import NumPy as NP. This is the short name of NumPy. And I want to create an array, try to understand, create an array using the list command and using the tuple command. That is very interesting. Already I told you, when you create a library package anywhere, we have to use the list, tuple, and dictionary. How we can use? So I want to create an array using this NumPy, that is NP short name. And this is my function name, np.array, and this is my arguments. This is my arguments. and this is saved into array underscore ID. The why I have given the first bracket and third bracket. First bracket, third bracket means create a list, and first bracket means it is unchangeable. You can never change. We can never change. Okay. Then we want to print that if ID array, so definitely this array will be printed. I want to print creating a 2D array, that is the matrix. So definitely we can give this value, say like 1, first 1, 2, 3, again another list, again another list. Already I told you, in a list we can create so many lists. Yeah, so many lists. So that is your 1, 2, 3, first row, second row, third row. Then we can, and that is, the name is the array underscore 2D 2 dimension, and we can create the 2-dimension array. Okay. And similarly, array with the zeros, array with the ones, so many things, array with the random variable, so many things we can create with the numpy NP. And always when you create the numpy with array, you have to give the short name. Then you understand, the Python will understand that you are using the numpy library. Okay. Because, and before that, you have to import the numpy as NP. Okay. And similarly, create array indexing slicing. So this total part I will show you in the tomorrow's class with the data set. Okay. Array indexing and array operation, so many things, element-wise addition, so many things, element-wise multiplication, array reshaping, array. What is the reshaping? Say, suppose if I take the 12 numbers, very interesting example, already I have sent you in my PPT. Already I've said that if I have some 12 observations, arrange 12 observations, and we can, these 12 observations, we can convert into 3x4 matrix, because 3 into 4 means 12. So automatically, since it is given as reshape 3, 4, that means it will create a matrix of 3 rows and 4 columns. And if I give the 4, 3, it will cope the 4 rows and 3 columns. It's a fantastic, that's the reshape command. Okay. And there's the matrix multiplication, we can do it. We can do it, the matrix, and you can use using NumPy as different statistical functions, the mean, median, standard deviation, basic functions. Say I have taken NP array like this, so we can calculate, and that is stepped under array underscore stats. So we can calculate np.mean array underscore stat. Array underscore stat means we are trying to get the mean of these 10 values. Okay, and that is saved into mean underscore L1 L. Similarly, we can calculate np underscore median L standard deviation. Very simple. Okay. Similarly, we can print the mean values, print the median values, and print the standard deviation values. And this is the key features and specification of NumPy. There are so many key features that so many key features. These are the so many key features. What are the key features? There's we can create n-dimensional array. We can, support the broadcasting. That is, what is the broadcasting means? We can create arrays of the different shapes and sizes. Okay. That is already I told you. Mathematical operations we can use, arithmetical operation, we can use linear algebra, statistical operation, and random sampling. And we can go for optimized performance, vectorization, integrations with the other libraries. So definitely, already I told you, there are so many other libraries like Pandas, Scikit, Matplotlib. So we can integrate NumPy with these libraries. Okay. And random module. Now my question is, why I'm saying this? You can ask me. So better, since we are doing course the Python mainly for the data science. And if you tell me, sir, my sample size is small, then will you use Python? My sample size is moderate, then we'll use the Python. So definitely I have to think about it. Question is why? Because small sample or moderate sample, there are so many softwares. But if I ask me just why you need Python, so my answer is if you go for big data, maybe that is not the machine learning data. Maybe that is not the data learning, deep learning data. In most of the cases, for our research, we are using the big data. So then we can apply Python. This is my first answer. Second thing, you can ask me, is that why this is written that so many arithmetical operations, so many linear algebra, so many statistical operations, so many random sampling, then written optimized performance, then written vectorization. Why? Because when you go for any data science analysis, that is basically divided into 5 parts. What are the 5 parts? What these data science or better to say big data analytics or machine learning, and deep learning, you have to know mainly the 5 subjects. So what are the 5 subjects? You have to know the statistics. And for the statistics, there are so many libraries are maintained. You have to know linear algebra. You have to know probability. You have to know calculus, and you have to know optimization. So these are called the 5 part for performing any data science operation. And if you tell me any method which will be coming under this, any method. So these are the parts. Suppose you say, sir, K-means clustering. So I will say, okay, this is coming under optimization. If you say, sir, I like to use the MCDM criteria, optimize, it will come under optimization. But if you want to know this MCDM, I am telling you a sequential relationship. If you want to MCDM, so you have to know non-parametric, for which you will be coming under statistics. So definitely, if you want to perform MCDM criteria using Python, so definitely we need so many libraries. One for some for the statistics, some for the data frame, and definitely some for performing. So that's why there are so many applications, we can use in the NumPy library. Okay. And so why it is, I'm telling you, there's another part is the random module. So if up to I have completed the NumPy library, and then I will go for the pandas. So if you have any question, then you ask. And thank you for your patience. Hello. My voice is audible?
Yes, sir.
Yes, sir.
So I hope you understand what the importance of this NumPy library. I hope you understand. So naturally, not today, tomorrow I will show you so many applications using this NumPy and Pandas library. And gradually I'll shift to the Scikit library. And definitely, since it is a beginner Python, so I'll not show you any machine learning application. So I'll show you some statistical application. And finally, I will end my class with the visualization, throughout the visualization. Because when we start our any data analysis, so that the first part is how to describe your data. This is the first part. Okay. So for the description, we know the descriptive analysis. That part tomorrow I will show you. And then the summarization part. And one is the summarization part, and another is the visualization. So visualization part is very important because maximum, anyone can understand if some data can be, used in a graph form. And give the graph, then easily you can visualize, okay, this is the high, this is the low, this is the medium. Easily you can, that's why visualization is very important. Not only that, now the research is coming from visualization, you can give your research part. From visualization, you can create your correlation part. From visualization, you can give your so many categorical variable concept. That part tomorrow I'll discuss. Okay. So if you have no question, then I'm shifting to the going to the another very, very important library, that is the Pandas. So Pandas also is the open source Python library used primarily for data manipulation and analysis. So that is, it provides the two primary data structures. That is the series and data frame. This is the most important part, series and data frame. So tomorrow, when I'll take the hands-on class using Google Colab, obviously, I will show these, what is the meaning of series and what is the meaning of data frame. Okay. So data frame, I'm telling, and actually which allow you to efficiently store and manipulate large data set. And Pandas, already I told you, that Pandas is built on top of NumPy. Because if NumPy, if you don't import, so definitely this Pandas work will not work. And that's why when you start our, very interesting, when you start our Python code in Google Colab or any editor, then first we write import NumPy as NP. Then import Pandas as NP, because it's on the top. That's why it is written. And making it highly efficient and powerful for data analysis. This is very efficient library Pandas. So I'm giving a simple example, then you can understand. I'm giving a very interesting example. Suppose I have a data set, try to understand why it is important. Suppose I have a data set of a matrix that is called data matrix, the 1000 by 50. I have a data set. That is the 1000 by 50 means there are 50,000 cell elements. But only for my research, I need 1000 by 10 variables. So initial data matrix is 1000 by 50. That is called initial data frame. Okay. And my data frame, again, I want to create another data frame of 1000 by 10. For some researcher, maybe from the same data, create another data frame of 1000 by 20. So how can we create? We need the Pandas library. So this is very important application of series and data frame. Series part tomorrow I will explain. And why is Pandas important? So this is data manipulation and cleaning. Already I told you that cleaning, transforming, reshaping data, handling missing values, filtering data, and performing. That means how we can solve the missing analysis. So using Panda, we can use missing analysis. Hyperform, like NumPy, Pandas offer fast and memory efficient operation for large data set and making it highly suitable for handling data in data science, machine learning, and scientific computing. So the data frame for 2D data and series for one-dimensional data abstraction are easy to understand and work with, providing a seamless way to interact with the tabular data. This is very interesting. That is called the intuitive data structures. So what is intuitive data structures? That we can handle the 1D data, one dimension, that is basically called series data. And when you go for the 2D, that is called the data frame. Okay. And integration with the other libraries, already NumPy. So Pandas integrates smoothly with the various libraries, including NumPy, Matplotlib, SciPy, Scikit-learn. Another very important library, it is not given here, that is the Seaborn library. Seaborn also integrated with the Pandas, very important library, which I'll use in the last class for the visualization. Mainly, I'll use the Seaborn library. Okay. Making it essential tool in the Python data science ecosystem. Now, where to use Pandas? The Pandas is commonly used in a wide variety of fields and tasks. We can use data analysis. Already I told you. What is data analysis? Summarizing, filtering, aggregating, and transforming. That is called data analysis. What is data clearing? Now clear the data, handling the missing values, removing duplicates, and normalizing the data. So that is called data clearing. What is time series analysis? Pandas provides powerful tools for working with the time series data. Resampling, shifting, and rolling windows, which are useful in fields like finance, economics, and signal processing. Question is why? Because in case of time series analysis, this is very important. Mainly we go for the panel data. Panel data. That's why we need this, the rolling windows. Machine learning pre-processing, it is used extensively in the pre-processing steps of machine learning workflow, including feature engineering, data scaling, and transformation of the data into suitable formats. This is very interesting, called feature engineering. Okay, I'm telling you, it's a very interesting story. Then you can understand. Suppose how the pandas will work on that. Suppose I have 20 features for prediction some dependent variable, and these 20 features initially when you start this, that means 20 features are independent, one is the dependent. So really I will be confused that how many features are important. Okay. And there are so many feature selection, feature engineering methods developed. That is, one is the wrapper method, one is the subset selection, and there are so many, forward, backward regression methods, so many methods developed. But how, what the problem? That's why this is called a feature engineering. But the problem is, if there are 20, features, and you want to go for only mathematics, then we can create a total 2 to the power 20 possibility subsets. 2 to the power 20 subsets, it takes a very, very high value, that is 10,48,576. So definitely we'll be mad after some times. So that's why we need some, process. We need some library. We need some software, so by which we can minimize it. That which are the important features. Yeah? Not only that, how can we remove the different types of, the assumptions of the different models, so that we can use the feature engineering. That part I will apply in the tomorrow's class. And that is the very interesting. You can go for the data scaling also. And scaling is very, very important part. I'm telling you. Why? In most of the cases, why scaling is important? In most of the cases, we are applying the correlation matrix because it is easy to use, and maximum software they can calculate easily. But I am telling you, when you go for machine learning tool like partial least square method, we have to apply the data scaling method. Because using the data scaling method, we can create a covariance matrix. And that's why it's very important. Okay, and because the partial scaling method is a machine learning tool. Okay. And the transformation of raw data into suitable formats, that is a very important application of this. And finally, this is the very interesting part, data visualization part. That is, while Pandas itself does not provide the advanced visualization capabilities, but integrates with some visualization library, or you can say package, or you can say module, that is the matplotlib or Seaborn library. Okay. Suppose when you want to plot the scatter plot, and if you import only NumPy-Panda, you cannot draw the scatter. So for the scatter plot, you have to import another library, that is the matplotlib. So, okay, so there are so many things. So there are so many graphs you can never Python pandas can never draw. So then then we need another library that is called the Seaborn library. So I'm giving some example. That is very interesting example that how can we creating a data frame using pandas. That means I want to create a data set. Because this is the main operation, series and data frame. A series creation easily we can form with the list command. Series creation we can easily create with the dictionary command. But when you go for the data frame, already I told you that is the 2D. Okay, so how can you create this? So that is the creating a data frame. That is the import pandas as a PD. PD is the short name of pandas. So this is my we know what is the dictionary. That is my key, single key, and these are the different values, because values is more than one. So we have taken 4 persons name, and there are 4 ages. And just you think, when I have written it is the list. Try to understand. And this, why this is list, we can change it. We can change the name Alice by my name Gautam. Bob I can change by any name, Anupam. Okay. Similarly, age, I can given any age. I can, that's why these are called the list. And that's why list is very important. And if you give the first bracket, so you can never change. So when you create a data frame using dictionary, you use the list command, because this is your key value and these are the values, key and values. And now after giving name, age and city, and these are the 4 records. Under name, these 4 names will be coming. Under age, these 4 values will be coming. And under city, these 4 city will be coming. And now we create this PD because pandas dot data frame, and this data is saved into data. This dictionary is saved into data. This dictionary is saved into data, and that's why I want to put the data. Okay. Now, and if we want to print, definitely. So I'm telling you, today I will, after my lecture, I will send this PPT. This PPT. Why? Because easily you can put in the Google Colab and you can get out. Simply you type the code. Then you can understand what is the meaning. Just you simply write import pandas as PD. When you start Google Colab today, after tomorrow I will show you that you simply import the 2 library. One is the pandas, another is the NumPy. Okay. So you put the data, and that is the. Similarly, I can put reading a CSV file. This is very interesting. Question is why already today you got so many CSV file I have sent. But you have to know how we can import a CSV file to Python. So that part tomorrow I will show you. That is simply assume you have a file data.csv. This is my file name. And if I pd.read underscore CSV dataset, and that is the print DFP, that means we can get the contents of the data.csv. And basic about the that is there are so many types of this: selecting columns, multiple columns, okay, selecting rows by index, selecting the multiple rows. These are the all option of pandas. Okay, filtering data, adding a new column, add a new column to the data frame. Okay, say how we can add this. Now filter rows based on a condition. So these are the so many queries we can solve using pandas. Okay, and so basically, yeah, this is the rename columns. These are some application handling missing values and fill the missing values, and this. So today I have discussed about NumPy as well as pandas. These are very useful. And after my class, I'll send you to the organizer. Obviously, they will send you. And it's my request that tomorrow, before starting the tomorrow's class, at least you put some thing in the Google Colab for the practice session. And for tomorrow, I'll go for the hands-on session using Google. And with the different example. So many examples I'll show you. Okay, so what is the meaning of series? What is the meaning of data frame? And how we create a data frame using pandas, using dictionary. Okay, but tomorrow I'll solve it. And up to this, if you have any question, you can ask me.
Hello, sir. I have a question.
Tell me.
Sir, can I call the NumPy in cell?
In?
So is it necessary to import NumPy in ideally cell?
Ideally
Ideally cell. If I want to write a program, so can I import the NumPy module?
I mean,
NumPy.
I'm telling you, actually, my practice is when I'm writing the Python code, when I write the Python code, my practice is first I import NumPy. Question is why? Because for any work, I have to use the number. Okay.
But sir, if I write import NumPy as NP, there is an error is showing.
Import NumPy as NP error is showing in Google Colab.
No, sir. In Ideally Cell.
Oh, ideal cell. Ideal cell, it will not come. Because in the ideal cell, you have to install the package library. Already I
Okay,
told
sir.
you. But if you write in
I
the
missed.
Google Colab, no need to import. No need to install the library.
Okay, sir.
Already I
Thank
told
you.
you.
I
I
missed that.
understand your question. Ideal cells. Oh, always I'm telling you, you go for, then you have to install by the package or library by the PIP set. PIP dot install dot this thing. That part I will show you. Yeah, how you install the library. But mainly from tomorrow, I understand your question. Mainly from tomorrow, I'll start only in the Google Colab, and that will be the hands-on. I will show you so many things. Okay, and then you can easily understand what are the application of NumPy and what are the application of Pandas. And similarly, day by day, I will show the application of so many libraries like Matplotlib or some applications, some example. And then I can show that how we can solve, because the time is a factor, how we solve some regression problem using simply Google Colab. And then very simple. Okay. And that is some fixed thing, because if you any kind of regression problem, if you want to solve, just you import the same thing, import the same library, and just you change your data set, your graph will be automatically coming, your analysis will be coming, and naturally your after getting the result mainly based on your interpretation. Okay, that part tomorrow I will show you. First of all, I would like to know, at least you get something about Python, that is what is library, what is package, what is module, what is function. And at least you understand that for all writing these, we need my conditional statement, my function statement, my data structure, my data type, and my variable. So these are the sequential process. There is a sequence of all this. And the main thing is how to write a library, and how to write a package, how to write a module, and how to write a function. Because for writing, because why? Because these are important. When you import the NumPy, automatically so many things inbuilt in NumPy. So many things will be in Pandas. Okay. But already I told you we can create so many inbuilt things. Also, we can define my user defined data frame. Suppose I am creating user my data frames. Also, but suppose if you import some file, that data frame is already created. That part already I told you. That if we like this, say this is equal data.csv, so already this data frame is created. That means if you, this is the DF means data frame, that means if you read this data frame, already the data frame will be coming. But if you want to create a data frame like this, you can create your own database. But what is the problem? Because it takes time. Suppose from the stock market, you are collecting some data. Okay. And data, that is some column names and some row. So you are collecting the data for 1,000 days. And there are so many macroeconomic parameters or anything else. So definitely that is, already the data set is given. And when this data set is given, easily you can save it into excel.csv and simply for analysis, import the file in Python. And just to check my file today, you got it, that so many CSV file I have sent. That's why I have sent the CSV file. And
Sir,
tomorrow
are the files, will the files be saved in data frames only?
Yeah, that is basically one data frame. Which I file I have sent, that is a data frame. Okay. But for my operation, maybe from this data frame, I have to create a new data frame. Suppose which I have sent, maybe that file is the 100 by 15. That is 100 rows and 15 columns. But for my research, I need only 5 columns. For my research, I no need of the 100 rows, so I can discard some rows. For my database, there are some missing values, so definitely I have to go for missing analysis. So that type of work we can solve by the pandas data. Is it clear?
Yes, sir, clear.
Okay, thank you. So actually, for our discussion, I'll not use the TensorFlow. Mainly, it is the machine learning. Okay, but I'll send you. You get it. So then you can understand why the TensorFlow is important. And this is basically used for machine learning. Say I'm telling you, you want to solve, the classification problem, so logistic regression. Then you need this. You want to solve, K-means clustering. You want to solve the Nebes. Okay. There are so many Markov chain, so many machine learning problems, so many, you have to want to solve random forest. You want to solve decision tree. You want to solve SVM. Then you need this. Is it okay? But now I'll not discuss this. Okay. TensorFlow. I'll not discuss this thing. I'll not give features, tensors. These are all features. These are examples. Okay. And PyTorch also. PyTorch also. And these are the example. Okay. And also it is a neural network problem. So GPU application, so many applications. Okay. And Keras also it is given. So mainly I try to cover through this note 5 library, mainly the 5 library, and obviously 5 library, mainly NumPy, pandas, and some packages like Seaborn and Matplotlib, and some when I solve the regression, then I will use some Scikit package library. So these will use for our case. Okay. For this course, obviously, course is designed for the beginners, I'm telling you. Okay. And now if it is extended, so obviously you can go for machine learning, deep learning, so many things. You can optimization, for the optimization purpose, you can build Python. Suppose some course based on some financial modeling. So then you go for financial modeling tensors, financial modeling, machine learning. Okay. So many things are using now to. So mainly we apply these SciPy and scikit-learn mainly. So I hope you understand. So from tomorrow I'll go for the hands-on session. Again I'm reading, and just after my class I will send this my notes today. And basically again I'm repeating. Basically you need to know, again repeating, summarizing. You need to know what is variable first. How many types of variable? Okay, this is the second. Then you have to know what is the data structure. Mainly you have to know list, tuple and dictionary. Sometime another dictionary set will be coming. Okay, set will be coming, which I have sent. That set also is given. Set is given. Then you have to know what are the loop function. There is a for loop, while loop. So many examples I have given, sent you. And then you have to know that what is the functions. That is in detail. Function is very important, because if you don't know function, how we prepare module, and after knowing module, you can prepare the packages. Already I told you it's come as a directory, and then you create the library. And I have shown the hierarchical visualization. Okay. And when you get the idea that why I need the NumPy, then you can get for NumPy for data analysis. Already I show you, and why you need for pandas. Okay. So mainly for our research, we need the statistical analysis and optimization analysis. Already to some analysis based on some based on probability and so on. Okay. So that for this you can use only I need for 5 to 6 libraries. So that through the 3 days I will show you this application of this 6 or 7, maximum 7 libraries. Okay. So I like to stop here, and if you have any question, so definitely if I know I'll try to answer. Hello. And thank you for patient hearing.
Thank you, sir.
Thank you. Thank you. Hello. So can I leave now?
Yes, sir. Yes, sir.
Okay. I'm leaving now. Huh?
Hello. Can we leave, sir? As sir already completed his session wonderfully. So can we leave? And I think the next session from tomorrow, it will be give on our mail as well as in WhatsApp also, because many participants me also having some problem, some issue regarding opening the link in the Google. So it will be better if you people give the link in WhatsApp. Hello.
Hello.
Yes, sir.
Uh,
Hello. Sir, one request. Just can you just give the link, that the Zoom link in our WhatsApp also, because some problem is created on our mail also. Whenever we are clicking on that particular link through mail, some issue are happening. So it will be better if you just post that link in our WhatsApp also, WhatsApp group.